All right, so the next lesson is on logarithmic functions. All right, so logarithmic functions are functions that can be written in the form, right? So there's actually two forms. Um, so this is like the more general log function. Now, this is a kind of a specific one, but in terms of properties, they're very, very similar. Okay, so yeah, so on your like scientific calculators, you may have noticed that there is a like a log button. So it is a function, but you also notice that there's probably a ln or ln function as well. So this is called the natural logarithm. Um, However, in the context of this course, you can actually just consider them being the same. All right, so whether it's log or ln, either one of these are just generally these are two types of log functions, right? Or actually more specifically, this natural logarithm is a specific log function. But anyways, just consider them the same. All right, so we're going to be looking at the graphs and comparing the equations to these, right? So the first example here, so we're given the graph of y equals 2 times log x. Right, so in this case, a in this case is 2. And we want to find the x-intercept and behavior domain range. All right. So the x-intercept, what you notice here is that the x-intercept is at 1. Right, so the x-intercept is at 1, 0. Okay. And behavior. This is similar to what we were looking at in the previous lesson. You can see here that the end behavior, so as x goes to the right, you can see that this is actually increasing. All right, so we can say that the end behavior is increasing. And domain. All right, so domain, if I was to run a scanner left to right, you notice that this function here, it kind of levels off and it goes along the y-axis. So it actually doesn't go into this part over here. So the domain here is that x is greater than 0. Okay, so from 0 on, there's a function on this side, but there's no function on this side of the function of the graph. Right? So, or of the y-axis. All right, so in this case, the domain here is x is greater than 0. Now the range again is a scanner if we go up and down. So you notice that, yes, this tail goes down forever. And actually, this looks like it does level off, but it actually does still go, it goes to the right forever, but it also goes up forever. So if it goes down forever and up forever, the range here would be all real numbers. All right. Cool. So that's basically the 4 things that we want to just pick out of this graph. The x-intercept's at 1. Yeah. And behavior is increasing. Domain is x is greater than 0. Range is all real numbers. Okay, so that's for this function here. Cool. Now let's do the next example here. So this time we're given the graph of y equals -3 ln x, y-intercept. Sorry, let's shouldn't say y-intercept. Let's just say x-intercept. Sorry, guys. There is no y-intercept. It never crosses the y-axis. So actually, it should be x-intercept. The end behavior, domain, and range. All right. So one of the things I just want to point out here is that there's no real difference whether it's log x or ln x. All right. So so basically, we can actually just answer the same types of questions, or we would get the actual same answers as if we were to actually look at the graph of y equals -3 log x. All right. The shape is a little bit different, and I'm going to show you that in Desmos, but in terms of finding these characteristics, it's actually the answers are going to be the same. Okay, so again, like I said at the beginning here, just consider log x and ln x as logarithmic functions. There's no real difference in terms of these characteristics when it comes to the functions themselves. All right, so the x-intercept is where it crosses the x-axis, and so let me scroll that down here. So you can see that it's right here. Okay, so again, the x-intercept here is at 1, 0. Right. Now this time the end behavior . you can see that the function is not increasing, but it's actually decreasing as it goes to the right. So yeah, so the end behavior here is decreasing. The domain, okay, so going left to right, you can see that it levels off, but it never actually crosses the y-axis. So there's no function over here around a scanner left to right, but there's always a function to the right of it, and this line here does go on forever to the right. So the domain here would be that x is greater than 0. And likewise, the range, all right, so if I ran a scanner up and down, this tail, you can see that it goes up forever. And even though it kind of looks like it levels off down here, and it does actually level off, but it still does go down forever. All right, so the range here would be all real numbers. All right. Okay, so yeah, so these are the two different types. One's increasing, one's decreasing. Now, the only difference between these two equations you'll notice here is that the a value here is positive, right? It's positive 2, and the function's increasing. Whereas over here, it's negative 3, and the function is decreasing. So real simple, if a is positive, it increases. If a is negative, then it decreases. What about the x-intercept? You'll see that the x-intercept is at 1. The x-intercept is at 1. So you know, this is just two examples. As it turns out, the x-intercept for log functions will always be at 1. Okay. And likewise, the domain here is x is greater than 0. Domain is x is greater than 0. Range is all real numbers. Range is all real numbers. Okay, so the domain for all log functions is x is greater than 0. The range is all real numbers. So I think I did summarize that here. And so all logarithmic functions of the form, these two forms, do not have a y-intercept. Okay, so they'll never cross the y-axis. The x-intercept of all log functions of this form again is always going to be 1. All right, so actually, you know what? What I'm going to do here is just kind of pull up the Desmos again, and we'll just kind of visually see what happens here. So, all right, so let's start off with like y equals I don't know, 3 times log x. All right, so again, you can see that it will never cross the y-axis, so it doesn't have a y-intercept. The x-intercept is 1, 0. Right? So whether it's 3 log x or 6 log x, you can see that the y-intercept is still at 1. Right? And log x still x-intercept's at 1. Right? And likewise, if I had like negative 4, it's still the x-intercept is 1. Right? And negative 8 still x-intercept. Right? So the x-intercept is always going to be at 1, 0. The other thing I want to point out here is that, yeah, whether, like I said in the lesson there, whether it's log x or ln x, they sure the shape is slightly different, but the characters are still the same. Whereas, again, the x-intercept is still at 1 for negative 8 ln x. So if I change that to 2 ln x, you still see that it's still at 1, 0. Right? So, yeah, so log functions, whether it's log or I call this ln x, you're still always going to have an x-intercept at 1, 0. All right. Cool. All right. So the next point here is that, yeah, if a is positive, the logarithmic function is increasing. And so it goes in this direction. If a is negative, conversely, then it's going to be decreasing. All right. So let's just take a look at that. What happens if I change this here to see that positive 2, it's increasing. Negative 2, it's decreasing. Right? So positive 7, it's increasing. Negative 7, it's decreasing. All right. So if a is positive, it increases. If a is negative, then it's decreasing. Again, same holds for if it's a log function as well. Right? So negative 7 log x decreasing, positive 7 log x increasing. Cool. All right, and yes, and these last 2 points have to do with domain and range. Okay, so the domain of all logarithmic functions is x is greater than 0. Okay, so this is true for all log functions, and the range here is all real numbers. Going up and down. All right, guys, cool. So that is logarithmic functions.